Alright, a section of roller coaster is in the shape of f of x is equal to negative x cubed minus 2x squared minus x plus 15, where x is between negative 2 and positive 2. Find all local extrema and explain what portion of the roller coaster they represent. Okay, so we're going to do this question by finding a combination. We're going to be using a combination of the first and second derivative test. The first derivative test is useful in determining critical points, which can express local maximum minimum, as well as intervals of increase and decrease. However, with the second derivative test, we can actually determine if these critical points are maximum minimum points, right? So I'm going to show you guys this, and let's start with the first derivative test. So I need to find the first derivative. F prime of x here is basically the derivative of negative x cubed minus 2x squared minus x plus 5 plus 15, plus 15. And in this case, f prime of x is equal to negative 3x squared minus 4x minus 1. Okay, and we can understand that the interval is between negative 2 and positive 2, right? To find our critical points, I'm going to let f prime of x equal 0, right? And this will actually find a critical number of x. So negative 3x squared minus 4x minus 1 is equal to 0, and then I'm going to factor this guy out, right? So if I do factor this out, I'm going to use this by decomposition. Two numbers add up to negative 4, then multiply to positive 3. Well, we can do negative 3x minus x minus 1 is equal to 0, right? Negative 3x, x plus 1 minus 1, x plus 1 is equal to 0. So we get negative 3x minus 1 times x plus 1 is equal to 0. Okay, so let's solve for these two critical points. So I'm going to let negative 3x minus 1 equals 0, move the 1 to the other side. Negative 3x is equal to 1, x is equal to negative 1 over 3. However, this is not in the interval, so we're going to omit this value. Okay, however, x plus 1 is, it is in the interval. Sorry about that. Made a mistake. So it is in the interval, so we don't have to omit the value. It's between negative 2 and positive 2. Let's take a look at the next factor. X is equal to negative 1, right? So x is equal to negative 1 is one of our second solution. Now, we want to find the local extrema, right? In order to find local extrema, we know that these are two critical points. They represent extrema. We just don't know whether it's a maximum or minimum point. So let's actually determine if it's a maximum or minimum point. So in this case, I'm going to do the second derivative test. Recall that in the second derivative test, if f double prime of x is greater than 0, it's concave up. And if it's a critical point, this critical point would represent a minimum point, right? If f double prime of x is less than 0, the graph is concave down, and if there is a critical point, this would represent a maximum point. Okay. Now, in this case, f double prime of x here is equal to the derivative of negative 3x squared minus 4x minus 1, which is basically negative 6x minus 4. Okay, so that's your second derivative function, right? And using my second derivative function, I'm going to test both of these points. So let's do that. Let's use a different color this time. So I'm going to do f double prime. I'm going to test negative 1/3. So you get negative 6 times negative 1/3 minus 4. And you can notice here that this is 2 minus 4, which is less than 0, right? It's negative 2, which is less than 0. So f double prime of negative 1/3 is less than 0. Because the negative 1/3 is a critical number of x, this point would therefore be concave down, and as a result, this should be a maximum point. So there is a maximum point that occurs at negative 1/3 and f of negative 1/3. Okay. And what we could do later is we can actually plug this into our function and determine that. Let's also test f double prime of negative 1. If I plug that in, I get negative 6 times negative 1 minus 4, which is 6 minus 4, which is greater than 0. So f double prime of negative 1 is greater than 0, so this tells us concave up, and because it's a critical number, it's going to occur as a minimum. Okay, so there should be a local minimum. There's a local minimum at basically negative 1 and f of negative 1. So what I'm going to do last is I'm going to figure out what these 2 points are. Okay, so we know that there's a maximum point when x is equal to negative 1/3 and a minimum point at x is equal to negative 1, right? So if I plug this value in, our function here, our original function f of x, and I'm just going to go back up, it's negative x cubed minus 2x squared minus x plus 15. So let's plug this in, right? So f of negative 1/3 is equal to negative 1/3 cubed minus 2 times negative 1/3. Right, there's a negative 1/3 here. Squared minus negative 1/3 plus 15. And if I crunch this out here, this is negative 1/27, right? Minus 2 times 1/9 plus 1/3 plus 15. Okay, and you can just kind of crunch that out. Right, so this is 1/27 minus 2/9 plus 1/3 plus 15. What you could do here is just multiply everything by 27. Well, multiply this by 27, make a common denominator of 27, right? So the lowest common denominator here is 27. And if you do that, right, this becomes, you multiply this by 3, this by 3, this by 9, this by 9. It's 1/27 minus 6/27 plus 9/27 plus 15, 15 times 27, which is 405 or 27. And if we crunch this out, we basically get 409 over 27. Okay, so your maximum point of the roller coaster occurs at negative 1/3 and 409 over 27. Okay, now to find the minimum point, right, we're just going to do the same thing, f of negative 1, right, and you can punch this in your calculator. Okay, so you get 1 minus 2 plus 1 plus 15, so you basically get 15, right? So f of negative 1 is 15, so you have a minimum point that occurs at negative 1 and 15. Okay, so that's really the idea, right? So one point here is the maximum, so we have a maximum that occurs in the roller coaster at x equal negative 1/3 and a minimum that occurs at x is equal to negative 1.